Hey there, and welcome to another edition of the Walton Engineering Podcast. I'm your host, Mr. Benton. Today on the podcast, we talk about wedges. Let's get started. Please follow these tips for a more efficient video viewing experience. Here's what I hope you'll understand after watching this video. Wedges function as a moving inclined plane, and this is kind of like a wedge that we use for splitting wood. And what it does is that as I whack on the top of this with something probably pretty heavy, it drives this in and it splits the wood out. So it functions as a moving inclined plane. The IMA is the distance of the effort over the distance of the resistance. Well, what this means is as I jam this wedge into that piece of lumber, my resistance, my effort is going to travel 10 inches and my resistance is going to travel 3 inches. So I'm going to get a pretty big IMA on this, right? So L over H is my IMA. Sort of sounds like an inclined plane, but remember, this is just a moving inclined plane. So if I want the AMA, I have to know what my forces are all about. Let's do an example. What's the IMA of the wedge on the right? Well, IMA uses what? Uses distances. So the IMA is going to be 10 inches. As I jam this wedge all the way in, I know that I'm going to spread this lumber 3 inches. So I'm going to get 10 over 3 or 3.33. So what's the AMA? Well, remember in the AMA I've got to use forces. So I've got the ratio of what? The ratio of the resistance force over the effort force. So the resistance force is 700 divided by 250. And so I get an answer of 2.8. So what's the efficiency of the wedge? Well, efficiency is the output over the input. So that's the actual, that's what I get out of the system, not including friction, divided by, well, what ideally would it be without any kind of losses? So that would be 2.8 over 3.3, and if I do the math, I get 84%. And again, if we ask ourselves the question, does that make sense? I think we get the answer, yes, it does, because it's less than 100%. We'll see you next time on the Walton Engineering Podcast. See ya.